Hello student, today we'll do prime time. So our learning objective in this chapters are common multiples and common factors, co-prime numbers for safekeeping treasure, divisibility test, prime numbers, prime factorization, fun with numbers. So all these things we are going to learn in this chapter. Start with introduction. In earlier classes, we have studied about the factors, multiple, prime and composite number. So about these things we have studied in earlier classes. In this chapter, we will review the concept of properties related to them and extend our study to include some new properties. First is common multiples and common factors. First we'll take multiples. The multiples of number are found by multiplying the number with any whole number. So if we multiply the number with any whole number, we'll get its multiples. So to get the multiple of the whole number, we simply multiply it by the counting number. For instance, to find the multiple of 6, what we'll do? We'll multiply it by 1, then 2, then 3 and so on. So we'll get its multiple. The product of these multiplication and give the multiples of 6. For example, find the multiples of whole number 3. So multiples of 3, 3 into 1, 3, 3 into 2, 6, 3 into 3, 9. Like this, we'll find the multiples of 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, all these are multiples of 3. Next example, we have to find out the multiples of 8. So what we'll do? We'll multiply 8 with the counting number like 1, 2, 3, 4, 5, 6 and so on. So we'll get 8, 16, 24, 32, 40, 48, 56, 64. All these are multiples of 8. Since you can keep multiplying the number by larger and larger whole numbers, there is no limit for the multiples of number can have. Therefore, every number has the endless list of multiples. So multiples are endless or infinite. Next is common multiples. Common multiples are the number that are multiplied to or more given number. To identify the common multiple, list the multiples of each number. Look at the number to appear in the both list. For example, let's find the common multiple of 30 and 45. So first we'll find out the multiples of 30 and multiples of 45. Now we'll see which are the multiples which come in both lists. From the above list, we can see that the 90 and 270. 270 are the first two common multiples of 30 and 45. Next is some important facts about the multiples. Every number is the smallest multiple of itself. Like 4 multiplied by 1, 4. So every number is the smallest multiple of itself. Every number is the multiples of 1. The number has an infinite number of multiples. All the multiples of numbers are greater than or equal to the number. So the smallest or least multiple of any number is the number itself. And all other multiples would be greater than that. Next is factors. Factors are the number that divide the given number exactly, leaving no remainder. So factors divide the given number exactly and leave no remainder. In other words, when we divide a number by as factor, it divides evenly. Factors are also the number that when multiplied together in the pair give the original number. Therefore, the factor is essentially a number that can act as the divisor for the another number. Like if we take the factors of 1. So 1 is the factor of 1. Factor of 2, that 2 factors 1 and 2. Factor of 3, 2 factors 1 and 3. Factors of 4, 1, 2 and 4. Like here, the factor for number 10 given here. So all these factors will divide the given number exactly. Clear? So all the number by which the whole number are divisible give another whole number are factor. Factor of 10, that are 1, 2, 5 and 10. If we divide number 10 by all these factors, it will exactly divide the given number. Now let's find the factor of 24. So 1 into 24, 24, 2 into 12, 24, 3 into 8, 24, 4 into 6, 24, 5 into what gives you 24? 24 is not in 5 table, so 5 is not the factor of 24. 6 into 4, 24, 7 is not the factor of 24, 8 is the factor of 24, 9 is not, 10 is not, 11 is not, 12 is factor of 24, and then 24. So hence 1, 2, 3, 4, 6, 8, 12, 24, these are the factor of 24. 5, 7, 9, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. These are not the factor of 24. Oh, clear? Note that when studying the factor of the number, we only consider positive integer. A factor cannot be the fraction or the decimal. Factor will never be a fraction or decimal also, since division by 0 is undefined. 0 cannot be the factor of any number. Next is least common multiple or LCM. The least common multiple of two numbers is smallest multiple that the both number divide without leaving a remainder. For example, find the LCM of 8 and 12. So what we'll do? First, we'll write the multiples of 8 and 12. Now we'll find the common multiples. Now the common multiples are 12 and 24. And which one is least? Least is 12. So 12 will be the LCM. Clear? Next is common factors. Common factors are the number that divide two or more number exactly. To find the common factor, list all the factor for each number. Then identify the number that appear in all lists. For example, let's find the common factor of 30 and 45. So we have to find the common factor of 30 and 45. So first we'll write all the factors of 30 and all the factors of 45. Now we'll see what are the common factors. 1, 3, 5, 15. These are the common factor. Clear? So these are the common factor. Therefore, the common factor for the 30 and 45 are 1, 3, 5 and 15. Next, important facts about the factors. So about a factor, a number had at least two factors. Every number have at least two factors, that are the 1 and the number itself. 1 is the smallest factor of every number. The number itself is the greatest factor of every number. All other factors will be less than that number. All other factors of the number are greater than 1 and smaller than the number itself. So greatest factor of any number is number itself. Now we'll take some example. Find first three common multiples of 6 and 8, 12 and 18. So we'll write the multiples of 6 and we'll write the multiples of 8. Now we'll find out what are the common multiples. So first three common multiple, if we see, they are 24, 48 and 72. In 12 and 18, we'll write multiples of 12 and 18 and find out the first three common multiples. So first three common multiples are 36, like here you can see, 36, then 72 and 108. These are the first three common multiples. Clear? Next example. Find all the multiples of 40 that lie between 310 and 410. So we have to find all the multiples of 40 between 310 and 410. So multiple of 40 are 40, 80, 120, 160, like this. And the multiples of 40 that lie between 310 and 410 are 320, 360 and 400. Clear? Next example. Find any three numbers that are multiples of 25 but not the multiples of 50. So number that the multiple of 25, we will write the multiples of 25. Now we'll write the multiples of 50. Hence the number that are multiple of 25 but not are the multiples of 50 are 25, 75, 125, 175, which are not in table, common in table. Clear? Next example, example 4. There are multiple of 3 always the multiple of 6. Is it necessary or essential that all the multiples of 3 is always the multiple of 6? So to find the solution, we'll find out all the multiples of 3, clear? And find out all the multiples of 6. We'll see that the multiples of 3 are not always the multiple of 6. As 9 is not the multiple of 6, 15 is not the multiple of 6, 21 is not the multiple of 6. Clear? Next example, find the common factor of 20, 28, 15 and 25, 35 and 50, 56 and 120. To find the common factor, first what we'll do? We'll find out the factor of the given number. So, factor of 20 are 1, 2, 4, 5, 10 and 20. Factor of 28 are 1, 2, 4, 7 and 28. Now, we have to find the common factor. Common factor are 1, 2, 4. These are the common factor. Clear? Factors of 15 are 1, 3, 5 and 15. Factor of 25 are 1, 5 and 25. Now, the common factor of 15 and 25 are 1 and 5. Clear? So, what we'll do? First, we'll find out all the factors and then we'll find out what are the common factors. Clear? 35 and 50. These are the factors 35 and these are the factors of 50. Now, the common factors are 1 and 5. Now, factors of 56. These are the factors of 56 and these are the factor of 120. Clear? Now, we will talk about the common factor that are 1, 2, 4 and 8. Clear? One more example. Find the common factor of 4, 8 and 12. So, first we will find out the factors of 4, 8 and 12 separately. Then we will see which are the common factor. So, in 4, 8 and 12. Common factors are 1, 2 and 4. And 5, 15 and 25 we will find out this factors separately and then we will see which are the common factor. So, we will see the common factors of 5, 15 and 25 are 1 and 5. Next is learning point 5.1. So, you have to practice all these questions. So, you will understand that how much you have learned the chapter. Next is prime numbers. Study the following tables. Here the numbers are given, their factors given. So, you can see that every whole number other than 0 and 1 possess at least 2 factors. So, you can see in this table that all the numbers except 0 and 1 have at least 2 factors. Here are the numbers 2, 3, 5 and 7. They have only 2 factors that are 1 and the number itself. These numbers are defined as the prime numbers. So, prime numbers are the number which have exactly 2 factors, 1 and the number itself. Clear? So, prime number, every whole number other than 0 and 1 which have only 2 factors is namely 1 and the number itself is called the prime number. Or 1 is not the prime number because it have only 1 factor. For example, 2 is a prime number because 2 has 2 factors, 2 and 1. 1 and the number itself. Similarly, 3, 5, 7, 13, 17, 19, they are the example of prime number. We see from the table of the above that the number 4, 6, 8, 9 and 10. So, 4, it have more than 2 factors. Similarly, 6, 8, 9 and 10, they have more than 2 factors. So, these numbers are defined as composite number. So, what are the composite number? The number that has at least 1 factor other than 1 itself, or the number which have more than 2 factors that are called composite number. For example, let us take the number 24. The factors of 24 are 12, 24, 8, 6, 4, 3, 2 and 1. So, 24 is what? 24 is a composite number because it has more than 2 factors. Again, the factor of 17 that are 1 and 17. So, 17 is a prime number because it has only 2 factors. Note, since the number 1 has only 1 factor, so it is neither prime nor composite number. Next, important facts about the numbers. 2 is the only even prime number. All the other prime numbers are odd, and we can say all other even numbers are composite. So, 2 is the only prime number, or that is even. 2 is the smallest prime number, 9 is the smallest odd composite number. 0 and 1 are neither prime nor composite. Every even number greater than 4 can be expressed as the sum of 2 odd prime number. For example, 8 we can express as 3 plus 5, 20 we can express as 17 plus 3, 44 we can express as 13 plus 31. Next is the sieve of Aristophanes. The Greek mathematician Aristophanes in the 3rd century BC discovered the simple method to identify the prime and composite number. According to him, the method is known as the sieve of Aristophanes because it helps us to find out the prime numbers between 1 to 100. He explained the method for the natural numbers 1 to 100 as follows. So this is the sieve of Aristophanes. So what we have to do? We have to strike out the 1, as we know 1 is neither prime nor composite. Now we'll run 2 because 2 is a prime number, and we will strike out all the multiples of 2 up to 100. Now we'll ring 3 and strike out all the multiples of 3 up to 99. Now we'll strike out 5 and we will ring the 5 and strike out all the multiples of 5. Then we'll ring the 7 and strike out all the multiples of 7. We'll continue till all the numbers are either encircled or crossed out. So all the encircled numbers are the prime numbers and the cross numbers are composite numbers. So there we obtain 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. All these are prime numbers between 1 to 100 except 1, because 1 is not composite, neither composite nor prime. Clear? Now we'll take some example. Example 1. Write all the prime numbers less than 20. So all the prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17 and 19. Next example, write all the composite number between 1 and 40. So composite number which have more than 2 factors. So these are all the composite number between 1 and 40. Example 3, list all the composite number between the following 10 and 18. So between 10 and 18, the composite numbers are 18, 12, 14, 15, 10 and 18 are 12, 14, 15 and 16. Clear? 61 and 69, 62, 63, 64, 65, 66 and 68. 91 and 96, all the composite numbers are 92, 93, 94 and 95. Now example 4. Write all the composite number less than 30. So you have to write all the composite number less than 30. Here is a list of all the composite number which are less than 30. Clear? Next example. Check whether or not the following are composite numbers. So 98 have more than 2 factors. So first we'll find out factors of 98. We'll see it has more than 2 factors. So it's a composite number. Clear? Similarly, 47 have only 2 factors, 1 and 47. So it's a prime number. Or 35, it have more than 2 factors. It's a composite number. Clear? The factors 69, 1, 3, 23 and 69 more than 2 factors, so it's a composite number. The factor 108 that have more than 2, so it's a composite number again. And the factors 19 are, there are 2 factors 1 and 19, so it's a prime number, it's not a composite number. Clear? The factor of 21 are 1, 3, 7 and 21, so it's a composite number. The factors of 103 are 1 and 103, so it's a prime number, not a composite number. Next is learning point 5.2. So you have to practice all the questions given here. Next is co-prime numbers for safekeeping treasure. So first we'll take twin primes. As the name shows, 2 prime numbers are said to be prime if there is only one composite number between them, like 3 and 5. So there is one composite number between them, that is 4. 5 and 7, 11 and 13, 17 and 19, 21 and 31, 41 and 43, 59 and 61, 71 and 73 are the pairs of prime between 1 and 100. Next is co-prime. Any 2 prime number are said to be co-prime if they have only 1 as a common factor. So any 2 numbers which have only 1 as the common factor, they are known as co-prime number. So all the consecutive number are co-prime number. For example, 2 and 3, 3 and 4, 4 and 5, they are co-prime numbers. Next is prime triplet. Triplet means set of 3. A set of 3 consecutive prime number is called the prime triplet. 3, 5, 7 is a prime triplet. Remember, one thing you should notice is the co-prime numbers are not necessarily both prime numbers. So it's not necessary that co-prime number should be prime number also. Any two prime numbers are always co-prime. Every even number other than 2 is a composite number. Next is prime factorization. Prime factorization is a process of breaking down the composite number into the product of prime numbers. So whenever we write any composite number as a form of product of their prime number, that is called the prime factorization. A prime number is a natural number that greater than 1 has no divisor other than 1 itself. The prime factorization, each factor of the prime number, and when multiplied together, they will give the original number. Next is steps for prime factorization. So we have to do what we have to do. We have to start by dividing the number by the smallest prime number possible and continue dividing by 2 until no longer divides evenly. Move to the next smallest prime number, that is 3, 5, 7, etc. and repeat the process. Continue until the quotient becomes 1. Now we'll take an example. Prime factors, factorization of 18. So first we'll divide by the smallest possible prime number, that is 2. We'll divide by 2, we'll get 9. Now 9 is not divisible by 2. So we'll divide it by 3. It will give 3. Now 3 is a prime number, it is divisible by 3 only. So it gives 1. Clear? So prime factorization of 18, that is 2 into 3, 2 into 3 into 3. Clear? Now prime factorization 60, that is 60 divided by 2 gives you 30, 30 divided by 2 gives you 15, 15 divided by 3 gives you 5, 5 divided by 5 gives you 1. So prime factorization will be 2 into 2 into 3 into 5. Clear? Next is prime factorization using the factor tree method. So 24 is a composite number. We'll divide by the smallest prime number, that is 2, we'll get 12. Here 12 is a composite number, we'll divide it again by 2, get 6. Again 6 is a composite number, we'll divide it by 2, we'll get 3. Now 2 and 3 are the prime numbers. So the prime factorization of 24 is 2 into 2 into 2 into 3. Clear? So what we'll do here? First we split up the number as the product of two factors. These factors are either prime or composite. The composite we further break up and the composite factor until we get all the prime factors of the number. The above examples show the prime factorization of 24 in 3 different ways and ring of the prime factor in each case obtained 3 into 2 into 2. So we have seen the prime factorization of 24 by 3 different ways. Here what we have done, we'll divide it by 3, we'll get 8. Now 8 we'll divide by 2, we'll get 4, and then we'll divide by 2, we'll get 2. Clear? So we have seen the prime factorization of 24 by 3 different ways. We shall now discuss prime factorization of 24 by division method. So this is a division method. 24 divided by 2 gives you 12. Again we'll divide by 2 gives you 6. Again we'll divide by 2 gives you 3. Now 3 is a prime number. So prime factorization, that is equals to 2 into 2 into 2 into 3. Next, using prime factorization to check if two numbers are co-prime. Two numbers are co-prime or relatively prime if they have no common factor other than 1. In other words, the greatest common factor or GCD, greatest common divisor, is 1. Now steps to check the two numbers are co-prime using the prime factorization. So for that, first we'll perform the prime factorization of each number, list the prime factor of each number, compare the list of prime factors. If two numbers have no prime factors common, they are co-prime numbers. If they share the prime factors, they are not co-prime, then they are co-prime numbers. So this way we can check. Now we'll take an example here. we have to check whether if 15 and 28 are co-prime numbers. So first we'll do the prime factorization of 15. Prime factor of 15 is 3 into 5 and prime factorization of 28, that is 2 into 2 into 7. Now we'll compare the prime factors. If there is any common factor, no, there is no common factor between 15 and 28, so they are co-prime numbers. Another example, we have to check whether 18 and 24 are co-prime numbers. So prime factorization of 18, that is 2 into 3 into 3, and prime factorization of 24, that is 2 into 2 into 2 into 3. Now compare the prime factors. So we can see there are common factors, so that means common factor 2 and 3, so that means they are not co-prime number. Clear? Next, using prime factorization to check if one number is divisible by another. To determine if one number, suppose that number is A, is divisible by another number and that number is B. Using the prime factorization, follow these steps. Perform prime factorization, find the prime factorization of both A and B. Now compare the prime factors, check if all the prime factors of B are present in A with the same or highest exponent. If in every prime factor B is present in A with the equal or higher exponent, then A is divisible by B. If any prime factor B is musing from A and has lower exponent, then A is not divisible by B. So this way we can check. Now here we'll take example, we'll understand this with example. Check if 80 is divisible by 45. So first we'll do the prime factorization of 180. 180, the prime factorization is 2 into 2 into 3 into 3 into 5. So that is 2 is to power 2, 3 is to power 2 into 5. Now we'll do the prime factorization of 45. So that is 3 is to power 2 into 5. Now we'll compare the prime factors. Clear? Now we'll check the exponent. For 3, 45 have 3 is to power 2 and 180 also has 3 is to power 2. For 5, 45 has 5 is to power 1, in 45 5 is to power 1 and 180 also have 5 is to power 1. Since 180 includes all the prime factors of the 45 in the same or the greater amount, that means 180 is divisible by 45. So this way we can check whether one number is divisible by another number. Another example, we have to check whether 100 is divisible by 30. So we'll do the prime factorization of 100 and 30 and we'll compare the factors. 30, that is equals to 2 into 3 into 5. Clear? Now prime factorization of 30, 2 is to power 1, 3 is to power 1 and 5 is to power 1. Prime factors for 100, that is 2 is to power 2 and 5 is to power 2. Now we'll check the exponent. For 2, 30 has 2 is to power 1 and 100 has 2 is to power 2. Clear? That is sufficient. For 5, 30 has 5 is to power 1 and 100 has 5 is to power 2. That is sufficient. For 30, we'll check for 3. 30 has 3 is to power 1 but 100 has no factor of 3. Since 100 does not have the prime factor 3, so 100 is not divisible by 30. Now we'll take some example. Example 1. Are the following pairs of number are co-prime? Guess first and then use the prime factorization to verify the answer. 30 and 45. Are they co-prime factors? No, they are not the prime factors. So we'll check factors of 30 and 45. These are the factors of 30 and 45. Common factor 3 and 5, that means they have common factors, so that means they are not the co-prime numbers. Clear? Factors of 57 and 85, these are the factors. Now they have no common factor other than 1, that means they are co-prime numbers. Factors of 121 and 1331. So common factors are 121, there are common factors 11 and 11, so they are not the pair of or co-prime numbers. Clear? Here we have to check whether 343 and 216 are co-prime numbers. So first we'll find the prime factors of both the numbers and see if there is any common factor. We'll see there is no common factor other than 1. So, they are the pair of prime factors. Now, we'll take example 2. Find the prime factorization of the following numbers. So, we have to do the prime factorization of following numbers. So, for 18, that is 1 into 2 into 3 into 3. So, we will divide the given number by prime numbers, possible smallest prime number, and write it as the product of prime number. So, that is the prime factorization. So, these are the prime factorization of given number. Now, we will take example 3. Do the prime factorization of 48. Write the factors in exponential form. So, this is the prime factorization of 48 divided by 2 gives you 24. Again, we will divide by 2 gives you 12. Again, we will divide by 2 gives you 6. Again, we will divide by 2, we will get 3. Now, 3 is a prime number. So, prime factorization, and that is equals to 2 into 2 into 2 into 3. Now, we have to write in exponential form. 2, how many times 2 is there? 4 times. 2 is to power 4 into 3. Clear? 4 into 3. 2 is to power 4, that is equals, written here, 2 is to power 4. Clear? That is the exponential form. Next example. Find the prime factorization of 128 and 1326. So, here we have done the prime factorization. 128 divided by 2 gives you 64. Again, divide by 2 gives you 32. Again, divide by 2 gives 16. Divided by 2 gives you 8. Divide by 4 gives you 4. Then, divide by 2 gives you 2. And 2 divided by 2 gives you 1. So, prime factorization 2 into 2 into 2 into 2 into 2 into 2. In the exponential form, that is equals to 2 is to power 7. Here the prime factorization of 1326. So, we will write in exponential form 2 into 3 into 17. Clear? Next is learning point 5.3. So, practice all the questions given in the exercise. Next is divisibility test. The divisibility rule enable us to know whether the particular number is divisible by the given number by, without doing actual division, we can tell whether the given number is divisible by that number. Clear? So, here we will review the divisibility rule for some number which you have already learned in the previous class. First, divisibility by 2. If a number ends with 0 or even number, like 0, 2, 4, 6 or 8, means a number have 0, 2, 4, 6 or 8 at one's place, that means the given number is divisible by 2. So, like here 244, 4 at one's place, here 0 at one's place, 6 at one's place. So, all these numbers are divisible by 2. Here 5 at one's place and 1 is at one's place and 7. So, these are odd number, that means that is not divisible by 2. Next is divisible to 4. If a number ends with 2 zeros or the number formed by its last 2 digit, means 1s and 10s digit is divisible by 4, that means the given number is divisible by 4. For example, 4300. So, it ends with 2 0, that means it is divisible by 4. Here the last 2 digit is forms 24 and 24 is divisible by 4, that means the given number is divisible by 4. All these numbers are not divisible by 4. Next is divisibility by 8. If a number ends in 3 digits or if the number formed by the last 3 digit is divisible by 8, then the given number is divisible by 8. For example, here 38,000, the number 8 with 3 zeros, that means it is divisible by 8. Here the last 3 digit 328 is divisible by 8, that means the given number is divisible by 8. Clear? So, this way we can check whether the given number is divisible by 8 or not. Clear? Next, divisibility by 5. If the number ends with 0 or 5, any number that ends with 0 or 5 or have 0, 5 at one's place is divisible by 5. For example, 45,385, 48,320, all that have 5 and 0 at one's place, that means they are divisible by 5. All these numbers, they don't have 0, 5 at one's place, that means they are not divisible by 5. Next is divisibility by 10. If a number ends with 0, that means it is divisible by 10. For example, 3250 ends with 0 all the numbers which end with 0 are divisible by 10. Clear? Next is divisibility by 3. If the sum of digits of the number is divisible by 3, then the given number is divisible by 3. For example, if we take a number 3522, sum of digit 3 plus 5 plus 2 plus 2, that is equals to 12, and 12 is divisible by 3, that means the given number is divisible by 3. 493, the sum of digit that is equals to 16, and 16 is not divisible by 3, that means 493 is not divisible by 3. Clear? Next is divisibility by 6. If a number is even and the sum of digit is divisible by 3, then the number is divisible by 6. For example, 3522, it is an even number and sum of digit is 12, and 12 is divisible by 3, that means the given number is divisible by 6. We'll take another number. Here the number is even and the sum of digit is 20, and 20 is not divisible by 3, so it's not divisible by 3, that means it is not divisible by 6. So a number to be divisible by 6, it should be divisible by 2 and 3 both. Next is divisibility by 9. If the sum of digit of the number is divisible by 9, that means the number is divisible by 9. For example, in the given number, sum of digit is 27 and 27 is divisible by 9, that means the given number is divisible by 9. Next is divisibility by 7. A number of 2 digit is divisible by 7 if the sum of 3 times of the digit in tens place and the digit in ones place is divisible by 7. We will understand this with the help of example. 63 divisible by 7 because 6 into 3. So, for that the sum of the 3 times of digit at tens place. Here the digit at tens place is 6. Multiply by 3, 6 3s are 18 plus the digit at ones place, total makes 21, and 21 is divisible by 7. A number of 3 or more digit is divisible by 7 if the sum of number formed by the last 2 digit and twice the number formed by the remaining digit is divisible by 7. Again, we will understand with help of example. 665 is divisible by 7. Why? Because 65 plus 2 into 6, that makes 65 plus 12, that is 77. Means if a number have 3 or more digit, in that case the sum of number formed by the last 2 digit, the sum of the number formed by the last 2 digit, that is 65, and twice of the number formed by remaining digit. Remaining digit is 6, 6 into 2, that is 77. Clear? That means the given number is divisible by 7. 1512, so 12 plus 15 into 2, that is 42. 42 is divisible by 7, that means the given number is divisible by 7. Next is divisibility by 11. If the difference between the sum of digit at odd place and the sum of digit at even place is either 0 or multiple of 11, that means the given number is divisible by 11. For example, consider a number, here this number. So, first we will make the sum of the digit at odd place, that is 9 plus 7 plus 0, 16, and sum of digit at even place, that is 16. The difference is 0, that means the given number is divisible by 11. To find if the number is a prime or not, to identify whether the number is prime or not, we will test its divisibility by a smaller prime number. We will take an example here is 8530 is divisible by 4. Since the last 2 digit, we know the divisibility rule of 4, last 2 digits should be divisible by 4. 36 is divisible by 4, that means the given number is divisible by 4. Clear? Now we will take another example, example 2. Find numbers between 120 and 140 that are divisible by 8. Also find the number between 1120 and 1140 and 3120 and 3140 that are divisible by 8. What do you observe? So, we will see the solution. The number between 120 and 140 that are divisible by 8 are 120, 128 and 136. The number between 1120, 1004, 140 that are divisible by 8 are 1120, 1128 and 1136. And number between 3120 and 3140 are 3120, 3128 and 3136. So what we have observed? We have observed that last two digits are the same in all the numbers. 20, 20, 20, 28, 28, 28. So last two digits are same. Clear? Now example 3. Find the largest prime number to be tested as a divisor to find the 83 is the prime number. Now we know 2, 3, 5, 7, so on, all these are prime number. Let us divide 83 by the number 2, 3, 7 and 11. So if we will divide by 2, remainder is 1. We will divide by 3, remainder is 2. Divide by 5, remainder is 3. Divide by 7, remainder is 6. Divide by 11, remainder is 6. Since the quotient 7 is the smaller, then the next prime number is 13. So we will stop at, because here the least quotient we get, 7 is the smallest, then the next prime number is 13. So we will stop at 11. Therefore 11 will be the largest prime number by which the divisibility need to be tested. 83 is not divisible by any prime number from 2 to 11, hence 83 is a prime number. Example 4, test whether 143 is a prime number or not. So 143 divided by 2, remainder is 1. We will divide by 3, remainder is 2. Keep dividing here, if we will divide by 11, we will get 0. So we see that 143 is exactly divisible by 13, so it is not the prime number, because it is exactly divisible by 11 and 13 both and 143, so it is not a prime number. Example 5, test whether 101 is a prime number or not. So we will divide 100 by 1 by all the prime numbers. So we will see, but the quotient 9 is less than, and the next prime number is 13. Here after 11, the next prime number is 13. So here the quotient is 9, in which is less than the next prime number, that is 13. So 9 is less than 13, that means is no need to test any further. 101 is a prime number. Clear? Next example, example 6. So we have to prove that 409 is a prime number. So we will divide 409 by all the prime numbers. So we will keep dividing. Here the quotient is 17, which is less than the next prime number, which is 29. So we cannot divide any further, that means 409 is a prime number. Next is learning point 5.4. So you have to practice all the questions given here in this exercise. Practice all the given questions. Next is summary. A number is the factor of another number if it divide it exactly without leaving the remainder. Prime numbers are the number like 2, 3, 5, 7, 11 and so on that have exactly two distinct factor, 1 and the number itself. Composite numbers are those like 4, 6, 8, 9 etc. which have more than two factors, meaning they have at least one factor in addition to 1 and the number itself. Every number greater than 1 can be expressed as the product of prime numbers, which is called as prime factorization. Except for the order of the factors, each number is a unique prime factorization. Two numbers are called co-prime numbers if they have no common factor other than 1. To determine if two numbers are co-prime number, we can find the prime factorization and check if there is no shared prime factors. If no common prime factor exists, that means the number are co-prime numbers. The number is considered as a factor of another if its prime factorization is contained within the prime factorization of the other number. So here we end the chapter. I hope you understand the chapter well. Now you have to practice this chapter.